the record. Okay. Fine. So today, what we are going to learn is it's an hierarchical clustering. We already come across whenever we are going to classify general clustering algorithms. We come across two types. One is partitional, another one is hierarchical. Is it right? So in partitional, one of the famous algorithm we studied, that is k-means algorithm, where when we plot a cluster or something, like we group points into some groups. Okay, so there we come across a very simple idea, that is any one of the points which belongs to one group, that is not at all belongs to other group. Is it right? So it means that each point belongs to only one group, or each data in a data set belongs to only one cluster. It does not belongs to other cluster. Is it right? That's what we come across in partitional clustering. And one of the famous algorithm in partitional clustering is k-means algorithm, where we are going to apply a very simple algorithm so that we can group a similar data into a single group and dissimilar with respect to other group. Is it right? So in the k-means algorithm only, we come across one another advancement in that, that is called bisecting k-means algorithm. Is it right? Which is an hybrid technique where we are going to merge hierarchical technique along with a partitional technique. That is, so we know that in hierarchical technique, if you are going college network, so that's why it happened like this. Okay, I have connected to mobile network now. It's fine. Okay. So I told that normally the classification with respect to clustering is either partitional way or either hierarchical way. In hierarchical way, we are going to cluster the data set based on a tree-like structure. So whatever the groups we are going to form based on similarity or dissimilarity, the final representation in the form of tree-like structures. So that's why we say it's an hierarchical clustering. Okay, you can be visualize the entire clustering in the form of dendrogram. Dendrogram, you can see it. Okay, so this is what dendrogram means. If you cluster, if it represented like this, that is a tree-like structure, then we are going to call it as a dendrogram. Okay, this is a tree-like diagram that records the sequences of merge or splits. So another way we can cluster using hierarchical clustering is using in the form of nested cluster. See, this is nested cluster and this is dendrogram. The two way we can represent our cluster using hierarchical clustering, one is in the form of dendrogram, another is in the form of nested clusters. So can you able to see nested cluster? See, so the cluster within another cluster, which is we call it as a nested cluster. Okay. Next thing, so what are the trends of hierarchical clustering? When we are going to choose, we want to cluster these particular data sets in the, by using hierarchical clustering techniques, when we need not to assume how many number of clusters. In k-means, so the cluster numbers always depends on the k value. Is it right? If you specify k is equal to 2, it means we are going to group our data with only 2 clusters. If it is k is equal to 5, we are going to group our data for number of clusters are 5 clusters. Is it right? But in hierarchical, there is no such k value. You don't have any k value. Means you are going to cluster the data, but you are not going to mention how many number of clusters. So if that is the case, then we are going to use hierarchical clustering. Okay. So it may be any desired number of clusters can be obtained by cutting the dendrogram at proper level. Okay. So you don't know how many cluster is going to become, because it is completely depends on the data sets and how the clusters can be obtained by cutting. Okay, that's the number of clusters you are going to achieve. Okay, so the best example is you are going to group your data based on their biological sciences like animal kingdom, uh, reconstruction, something like that. Okay. So we already come across this. Whenever we say hierarchical clustering, we have two types of hierarchical clustering. One is agglomerative, another one is divisive. We know that in agglomerative, all the data starts with as a single group. Then we go on divide the single group into multiple subgroups. Okay, and again we are go on divide the subgroups into again subgroups of that. Okay, until where we are going to do that until each consists of only one item. Until what? Each group consists of only one item. That is what we called it as an agglomerative clustering. Okay. And one more is there, that is divisive, is completely opposite to agglomerative, where we'll start with individual item. Each cluster consists of only one item, and then we are going merging the items, okay, into a cluster where it consists of more than one items. Okay, until what? Where we are going to end our clustering? Once we have only one cluster which consists of all the data in a data set, then we are going to end that. So this is what divisive method. Another one is agglomerative method. So these are the two techniques which are involved in hierarchical clustering. Okay. So, and one more thing I want to mention, in hierarchical clustering, you need not to mention k value. That you need to remain partitional. It is a instance we are going to select. But here there is no such thing. You don't have any authority to mention this number of cluster. You have to give the data sets into this algorithm. The algorithm is going to form number of clusters. The number of clusters always depends on how many number of partitions we are going to achieve with respect to these data sets, and how we are going to either split or how we are going to either merge these data. So based on that, number of cluster is going to be achieved. Okay. So whenever we say hierarchical clustering, of course, it is a very simple technique, that is either merge one cluster at a time or either split one cluster at a time. Okay, or merge two clusters into a single cluster or split one cluster into two clusters like this. So either you do merge operation or split operation. Merge operation is nothing but divisive. Okay, split operation is nothing but agglomerative. And one more thing is in hierarchical clustering, the most familiar using algorithm is agglomerative rather than divisive. That's why, so in our syllabus also we have agglomerative. We are going to learn how actually we are going to form a cluster using agglomerative hierarchical clustering technique. Okay, so how it works. So okay, my question. Any doubt in this? The differences between agglomerative and divisive? Any doubts? So there are 81 members. I need response from everybody. Okay, I need a response from everybody so that I'll understand. So who are all there in this class and who are not listening anything, do it fast. Actually, I'm in a class college. Okay, anybody come and anybody can see, even principal, HOD, anybody can see here. Okay, so better you just response here. Do it fast. I don't want to waste. Okay, so I think nobody have doubts. Okay, I'll go with the example. Let us assume we have some sample data like this. Okay, so how we are going to achieve our hierarchical clustering with respect to this data set? That is our task, is it right? So I already told that. So the most familiar using hierarchical clustering is agglomerative. That's why we are going to perform agglomerative clustering with respect to this sample data. Okay. So the first point is we want to uh, okay, we will just go and see in the sample data here. Okay, so each point in this graph represent a data in a data set. Okay, and we have to group this data as a cluster. So cluster is nothing but all similar data set data belongs to a single cluster, and dissimilar always have a more distance between each clusters. Okay, so what we do is we have a data sample now. We are going to apply the agglomerative algorithm for this, and we are going to group the data into either similar group or dissimilar group. Okay. The next step is what? This is where we will start with agglomerative. First, what we do is we are going to consider the two closest clusters and make them as a one cluster. We know that agglomerative work in terms of split operation. It is not like a merge operation. Okay. First, so we have entire data as a single cluster. Is it right? Entire data as a single cluster. Initially, we start with. Okay. Now we want to assume, we want to apply the agglomerative technique. See, so first step of agglomerative technique is you see how closest clusters are there in this given data set. Okay. So initially it's all starts with each point as a separate cluster. Okay, each point as a separate cluster. It's an agglomerative operation. Okay. Initially it started with each point as a separate cluster. Now I want to do merge operation. Okay. Sorry, it's a merge operation. I just sorry for that. Okay, it's a merge operation. Okay, now I want to do merge operation. Okay, so initially everything is a separate cluster. Okay, so now I want to merge two cluster. Which two cluster I have to select? That is the first task of our agglomerative technique. Is it right? So the option is very simple. I want to choose what? Two closest clusters. I want to choose what? Two closest clusters, and I'm going to make them as a one cluster. See, so among all these clusters, these two are closest to each other. Is it right? So that's why I'm going to merge these two as a single cluster. So now these two clusters are merged into a single cluster. Okay. Next step is what? I'm going to apply the same rule for the entire data set until finally I'm going to reach what? Only one cluster. So like that. Is it right? The first step I have applied here. These two are very close with each other, so that's why I found merging them as a one cluster. Okay. Next, with this cluster, I'm going to see any other clusters are closer with each other. Okay. Suppose if I can see that this cluster and this cluster close each other, I cannot grow because the distance is not close with each other. If I consider the distance between this one and this one, okay, with respect to this, so maybe this one is very nearer when compared to here. Is it right? What I do is I'm going to group it as a cluster 2. This is a cluster 1 and this is a cluster 2, and I'm going to see whether this cluster distance to this cluster, or whether this cluster distance to this cluster, or this cluster distance to this cluster, which one is minimum now. So usually we can easily see that. See, the difference between see the distance between year to year and year to year, this one is somewhat near to each other. Is it right? So what I do is my third cluster is this one. Okay. Next, my fourth cluster is what? This one. Okay. And final cluster is merging all these things. This is what agglomerative technique means. Okay. Initially, what we do, we will group the two cluster which are very near to each other as a single cluster. Again, we will check whether this cluster distance with other cluster, which one is minimum. Okay. So it is not necessary that you can merge directly from the group one. Okay. First, you can see the distance between these two. This is okay. Like the distance between next step. Okay. Anyhow, first step is finished. Is it right? First step, the closest clusters are these two. Next, I have to check which are the closest cluster with each other. Okay. So now, in order to check the closest cluster in the second step, I want to take a distance from year to year. I want to take a distance from year to year. I want to take a distance from others also, like year to year or like year to year. Meanwhile, this is the distance with respect to this cluster. Is it right? Like that, I have to do with this one also. Distance between year to year, okay, year to year, and year to year. So I will check which distance is smaller when compared to other distances. Okay, you can easily see by calculating the distances. The formula we are going to apply to calculate the distance is Euclidean distance formula. Okay, Euclidean distance formula. So by using Euclidean, you can easily see what is the exact distance between each point is nothing but each cluster to other clusters. So when you can when you consider the Euclidean distance, we are going to see which distance is very minimum. Okay, we are going to select that distance. So what I do is, suppose if the distance between these 2 points when compared to these 2 points is minimum, then I'm going to form the second cluster here. Okay, second cluster here. So I can again I am going to check whether the distance between year to year is minimum or year to year is minimum. So we can easily check that the distance is year minimum. So I'm going to form the third cluster here. Okay. Next, we can see that easily that the distance between year to year is minimum. Okay, I'm going to form the fourth cluster here. Okay, and finally, I'm going to form the fifth cluster. That is distance between this cluster and this cluster. Okay, fifth cluster. So totally, we have single cluster. Finally, this is what agglomerative technique means. Okay, this is how it will works. Okay, finally, we will end the agglomerative technique once we have the final only one cluster. Okay. So this is the algorithm for agglomerative clustering technique. Okay, first what we do, we start initially with each individual item as a separate cluster. Next, we are going to perform the Euclidean distance construction. That is, we are going to construct the proximity matrix where we are going to, the proximity matrix is very simple. See, suppose if we have 5 points means I'm going to write all 5 points like this. Okay, suppose assume I have 4 points. Okay, suppose I have 4 points. Okay, now what exactly proximity matrix represents here? It is we are going to represent the distance between each cluster to another clusters or each point to other point. Okay, so suppose we know that the distance between 1 to 1 is always 0. Like that, the distance between 2 to 2 always 0, 3 to 3 always 0, or 4 to 4 always 0. And rest distance, if it is the distance between 1 to 2 is 5, then here also 5. Okay, if the distance between 1 to 3 is 7, okay, here also it's 7. Okay, if the distance between 1 to 4 is 3, here also it is 3. Like that, the distance between 2 to 2 is 0, 2 to 3 is, assume I have 2, here also it is 2. And suppose distance between 2 to 4 is something like 9, here also it is, sorry, here also, yeah, here also it is 9. 3 to distance is 9 means here also it is 9, like that. This is what proximity matrix means. Here we have each point represents the Euclidean distance between each point. Okay, each value here in the proximity matrix represents the Euclidean distance between each points. See, this is the distance between 1 and 1. This is the distance between 2 and 1, 2 and 1. Okay, this is the distance between 3 and 1, like that. So, okay, if we have proximity matrix, then it is easy to calculate which one is the minimum distance and which one is the maximum distance and which one is the average distance, like that. Okay, so if you know which one is the minimum distance, what we are going to do is we are going to merge the two clusters which are closer. Okay, we are going to merge the two clusters which are closer with each other. Okay, then we will update the proximity matrix. Okay, again we are going to update based on the now new cluster as far initially everything is a new single cluster. Now when you are updated means either two item become a single cluster. Again we are going to merge it and we are going to form the proximity matrix until when we are going to stop our operation, until when every points in a given data are merged into a single cluster, then we are going to end this algorithm or we are going to end this technique. Okay, clustering technique. This is what agglomerative clustering algorithm means. Okay, so very simple. Whatever the data set they have given, initially consider each data set as a separate class. Okay, each data set as a separate class or separate cluster. Then you find what is the distance between each cluster to another clusters. Then go on select with any two cluster they are closest with each other and merge those cluster. Okay, until where you are going to stop your operation, when every points or every cluster in your data set becomes a single cluster. There you are going to stop your operation. That is what agglomerative. Okay. So there are numerous ways we can achieve the closest cluster. Okay. So either you can form a closest cluster based on the minimum distance, or based on the maximum distance, or based on the average distance, or based on the distance between the centroids. This is what we call Watt's method. Okay. This is Watt's method. Okay. So either any one of the technique we are going to use in order to merge the two clusters. Either it's based on minimum distance between the 2 points, or maximum distance between the 2 points in a cluster, or average distance between each point of one cluster with each other points of another clusters, or directly we are going to select the centroid points and the distance between these two centroid points. So using either technique, we are going to merge any two cluster into single cluster. Okay. So I'm going to take the names. Okay. Right. Now, the first method is we are going to achieve the clustering using agglomerative cluster technique by applying a minimum distance technique. Okay. So we are going to achieve agglomerative. How we are going to merge any two cluster into single cluster by using minimum technique? It is very simple. What we do is, in this cluster we have a 4 points. In this cluster we have a 4 points. I'm going to calculate distance between each point to. So I am going to select which one is the closest point to this particular cluster. Here we can easily see this cluster is the closest point to this particular cluster. Is it right? Like that, in this cluster also, this point is the closest point with respect to this cluster. I'm going to find the distance between these 2 points. Okay. So distance between, like that, you can even calculate any distance between this to this, or this to this, anything. But okay, once you calculate it, you will find only 2 points that have less distances when compared to other points. Is it right? So you can easily check here. This point is very near to this point. Okay, this point belongs to one cluster and this point belongs to one cluster. What we do is, we are going to select the distance between any 2 points in both the cluster. They are very they are in a less distance. Okay, when compared to other distances. Okay, so we are going to select those 2 points in order to. So with respect to other clusters also, we are going to select this. Okay, then we are going to select which clusters we have to merge. Okay, again I will give one more example. Don't be confused. See, suppose we have uh, numerous clusters. This. Okay, our task is which clusters I have to select in order to do merge operation. This is what we have to do. Is it right? So then, so by applying minimum method, how we are going to select which clusters I need to select in order to merge, whether I have to select this one and this one, or this one and this one, or this one and this one. So based on that minimum technique, is it right? Assume I have multiple points. Okay, here one point is there, 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 here one point. So have a cluster like this. Okay. See, I want to calculate a now I want to merge any two clusters. Is it right? Now I want to calculate a distance between this point to this point. Okay. I want to calculate a distance between this point to this point, and I want to calculate a distance between this point to this point. Like that, I want to calculate a distance between any two closest points of two different clusters. We can see these two are the closest point of these two clusters, and these two are the closest point of these two clusters, and these two are the closest point of these two clusters. Among these distances, which one is minimum? We are going to select those clusters to merge using this minimum technique. That's all. Okay. The next thing is maximum technique. Okay. Here also we do the same thing, but here what we do is we are going to select the farthest point rather than the nearest point here. So in maximum, we are going to select each point. So first calculate the distance between each point to other points of another cluster. Okay, here I'm going to calculate the distance here. I'm going to calculate the distance between this one and this one. I'm going to calculate the distance between this one and this one. Like that, I'm going to calculate the distance between this one and this one. Okay. So once I calculated all the distances, why I'm okay. Again, I will show you. Very okay. I'm going to apply the maximum technique now. Okay. Now this is our initial clusters. Now we have to select any two cluster to merge it. Is it right? By applying a maximum technique. Now our task is we are not going to choose now the closest points in each cluster. Okay. Rather we are going to select the farthest point here. So when compared to these two clusters, these two are nearest with each other. Is it right? But these two are farthest with each other. We instead of calculating this distance, we will select the distance of these 2 points in maximum technique. Like that, here both are in same distance, we will select this one. Okay, like that here, this is the farthest point to this point and this point. Is it right? Like that, this is the farthest point to this point and this point. Like that, this is the farthest point to this point and this one, and this is the farthest point to this cluster. Is it right? So we will calculate all the distances with respect to farthest points between the cluster. Once you know the distances, then among these distances, we are going to select the minimum distances among this. So among the maximum distances between each farthest point in a cluster between the cluster, there I am going to select the minimum distance. Then based on that, we can easily see these two I can merge it. So these two clusters I am going to merge it. Okay. The same thing here, what we do in the next thing is another technique what we are going to use is a distance between centroids. This is, we call it as a Watt's method. Okay. A technique name is called Watt's method. Okay. Here what we do, instead of considering points to calculate a distance, we will consider a centroid of each cluster. Okay, centroid. Assume this is a centroid of this cluster, and this is a centroid of this cluster. This is a centroid of this cluster. In this cluster, it is a centroid. Okay. Now I'm going to calculate the distance between these centers rather than with the points. Okay. So first I'm going to find the distance between these two. Like that, distance between these two, distance between this one, distance between this one, and distance between this one. So once I find the distances between each centroid point with centroid point of other clusters, then I am going to select which is the distance having less distances when comparing with all other distances. Then I am going to merge those clusters as a single cluster. This is what Watt's method will do. Okay. So mainly uh, four types. One I have explained minimum, another one is maximum, another one is Watt's method. One more is there, that is group average. So in group average, what we do is we are not going to consider only closest point or only farthest point. What we do in this group average is we will consider each and every point of a cluster okay here, and we are going to calculate a distance between each and every point of the cluster of other cluster